Good morning, everyone. How's everyone doing? Thanks for joining us this early after such an exciting concert last night. Good to see everyone here in the room. Hope you have some coffee already. In this session, we're going to talk about how Gemini-based agents, AlphaEvolve and Co-Scientist, can help you accelerate scientific discovery and optimization. So we have brought 3 additional customers with us today who are going to talk about their experience using Co-Scientist and AlphaEvolve. So really excited to hear from them how they're using these agents to accelerate their R&D. So I'm Tom. I'm at Google for more than 15 years now. I've been working on search and ads and cloud, and I'm responsible for Co-Scientist and AlphaEvolve. So we're going to start with an introduction into how Google is thinking about accelerating R&D with generative AI capabilities, and then specifically dive into Co-Scientist and AlphaEvolve. Then we're going to hear from Roche about their use of Co-Scientist, and then Klarna and FM Logistics about how they've been using AlphaEvolve before I'm going to wrap it up quickly at the end. So Google really has a long history in scientific breakthroughs. This is just a few of the inventions that happened in the last few years, right? So it started with we talked about TPU. We just announced the 8th generation of our TPU chip. Then innovations like AlphaGo for playing chess, to the next level of capabilities. WaveNet, a technology to synthesize speech. Then, of course, the transformer architecture developed at Google, which is the foundational underpinning for all of the LLMs that we see in the market today. And then fast forward, just released last year's AlphaEvolve, they're going to talk about today for algorithmic optimization, and also just very recently, also AlphaGenome, very domain-specific model to help with the understanding of the human genome. And we want to make sure as quickly as possible that we can bring these Google research innovations to cloud customers. And that's the primary focus of the team. So today we're going to talk about 2 specific R&D related agents. One is Co-Scientist and the other one is AlphaEvolve. Both of them are available in private preview today. And they serve slightly different purposes. So let me talk about Co-Scientist first. So Co-Scientist is a hypothesis generator and validator. So even though it uses Gemini under the hood, it's a long-running agent that might run for 12 hours, 24 hours, or even longer, and go extremely deep in very specific research topics. So it's built on Gemini 3 technologies. But instead of running just a single Gemini iteration, it's a long-running agent that is iteratively refining and reasoning over very difficult and very domain-specific topics. And the way Co-Scientist works is for us the idea that first understanding the underlying domain knowledge. So it's building up a knowledge base. And then it is starting to generate initial ideas. And those ideas are being compared to each other. They're being critiqued. And then there's an evolutionary process, kind of similar to AlphaEvolve, where those ideas are then being further developed and further improved. And then it uses a competition similar to chess, where you have an ELO rating where you compare 2 ideas against each other, and based also on the underlying critique, the model is then deciding which idea is better, and that creates an overall ranking of the ideas, which produces a ranked list of hypotheses. Underlying all of these is Gemini 3 as the underlying foundational model, but we're also integrating data that you have provided to the agent, and that's done in an enterprise compliant way. There might be computational tools that you might use under the hood, right? Those might be models like AlphaGenome that are used under the hood to validate and try to further improve the underlying ideas. And we have been working very closely with research institutions all around the world to test Co-Scientist. This has been going on for like the last 6 to 9 months or so. Here are like 3 recent publications where we've been working with like Imperial College London, Houston Methodist Hospital, and also Stanford University. To use Co-Scientist for scientific discovery, and has been very successful in actually accelerating and also defining actually new ideas that were not seen by scientists before. We're also excited to share, Amin talked about this like at the keynote, that Co-Scientist is also being used by US national labs as part of the Genesis mission in collaboration with the US Department of Energy. And it's now being used across like a number of customers. We're going to hear from Roche in just a second, to further accelerate like the scientific process, the research and discovery. Now I'm going to talk about AlphaEvolve. AlphaEvolve is an optimizer for algorithms, but it doesn't really stop like at algorithms. It really also can materially improve like real-world applications and optimization. The way AlphaEvolve works, it is starting with like an initial solution to a particular problem, and is then optimizing like these ideas through an evolutionary process. And we see many applications where this is used like for semiconductor design. And we've been using it also to optimize our own TPUs. You can use it for logistics problems. We're going to hear from FM Logistics later on in the presentation. It can be used to improve model training. So it's like a very wide array of applications where AlphaEvolve can be used. And this is kind of showing you how, like as an illustration, how AlphaEvolve is continuously improving like the underlying solution by mutating, by changing parts of the underlying code. And then a validation loop is then performed to see how that newly created program is then performing. And to give you like maybe like a more specific example, this is the traveling salesman example. This is like a very common example within computer science. The goal is basically you have like a single salesperson here, and you have to they have to visit a number of cities, and you have to find the shortest path so that they have visited every city at least once. And to make this problem like more interesting, we actually have like multiple salespeople, and we also want to make sure that they are roughly they can go back to like the family like in the evening. So we want to actually find the shortest maximum path across like all the salesmen, so that that's not like a single salesman basically visiting all the others, all the cities, and the other salesman can just like go home very quickly. So this is what I've been running like over the, it shows how AlphaEvolve is continuously improving, like as you go into like further iterations, how it's continuously improving like the underlying solutions. So at the end, after like I think 63 iterations or so, you see like a 42 improvement in the overall capabilities of the program. And you can see that even though there's a big improvement at the very beginning of the solution, it continuously to find like new best solutions along the way. And because this is all based on Gemini, you can also, like, there's a lot of explainability as well, like that's being provided here. So if I asked the Gemini, what kind of algorithmic improvements did AlphaEvolve discover when you compare the best program versus like the underlying baseline? So then it describes very clearly to me like which algorithmic techniques it had discovered to make these kinds of improvements. And you can see here it's like a 5-stage process to optimize like the overall performance of the program. So AlphaEvolve is very good at identifying solutions from very particular like domains and apply them to this particular use case. What I think is also like very interesting is that as an end user, I can care much more about the what, like the outcome. And AlphaEvolve really solves like the underlying how this is being done. So as a business user, if there's an additional constraint that I have, like in my supply chain optimization, for example, there's an additional constraint, or if I think about how to place cell towers, there's an additional business constraint, additional business goal. I can add this goal to AlphaEvolve, and AlphaEvolve does basically like all the underlying hard work and discovers the best algorithms to actually find the best solutions for me. And to make this more accessible to more customers, we've been integrating also developing skills for AlphaEvolve. So this video shows you how you can use skills basically in any IDE that supports skills. So here I'm selecting the underlying initial solution, and I'm going to tell here Gemini that it should be using AlphaEvolve to optimize this particular function. I point it to the project configuration, and I tell it how to evaluate the solutions. I also tell it to be creative, because I think that can't really hurt. And then automatically, now Gemini is optimizing, starting to understand like the underlying problem space, looks at all the code like in the code base. It suggests like particular constraints here, like of the experiments. I can go through these. I can look at them, make changes. Here, I just said like these changes look all good to me. And then it's like working through the experiment configuration. It runs a few underlying tests to make sure things are actually working. So I can really interact with it in just natural language, right? Which makes it like extremely powerful and much more accessible than previous approaches to solving these very hard computer science optimization problems. Right, so I gave it the go-ahead, and now it's running the AlphaEvolve optimization loop. And then it creates like an underlying dashboard where you can see the programs being generated and how they improved. I also want to visualize the underlying results. So I just tell it, please create a visualization of how things actually improved over time, so you can see like how things are improving after just like 7 iterations or so. And then I also want to be able to understand what it actually did. So I asked Gemini, hey, can you compare the best solution to the initial program? And it just creates in natural language it tells me which particular improvements were found by AlphaEvolve in this example. So we think with skills, we make AlphaEvolve much more accessible to many more customers. We're really excited about that. Yeah, so we've been using AlphaEvolve for quite some time already, at Google. So we've been using it for data center optimization, to optimize power consumption. We've been optimizing it for our chip design, so for TPUs. We've been using it for LLM training and inference to optimize Gemini generally. And we have seen significant improvements across a variety of domains. We've also been looking at using AlphaEvolve to look at 50 open questions within kind of combinatorics or other mathematical domains. And in many cases, in 75% of the cases, it rediscovered the existing or original known to be best solution. And in 20% of the cases, it was actually able to find new state-of-the-art solutions that were better than the previously known solutions. And we've also seen many customers starting to use AlphaEvolve across many different domains. If you take WPP, for example, they've been using it as an advertising agency, using it to optimize campaign performance. We use it for BSF, which is supply chain optimization. And we're also going to hear from Klarna and FM Logistic in just a second about their specific use cases. Now I'm going to hand it over to Ercan to talk about their use of Co-Scientist. Thank you.
Thank you, Tom. Good morning, everyone. So today I want to show you or share our experience how we evaluate Google's Co-Scientist on real R&D questions across the whole organization. So this was not a sandbox exercise or a demo-driven pilot. We really tested in a live program in the drug development pipeline. So the science matters. We had hard timelines, and the downstream decisions are really costly in our daily work. I will also take you through a real concrete example and what really changed for us in our organization. My name is Ercan. I'm leading the PSAI incubator from Pharma R&D at Roche, located in Switzerland. Let me go. This is kind of a bold statement, but this was a real quote from one of our scientists, and it says a lot. So what got people's attention was not that the tool produced a polished answer, like a custom GPT or kind of a chatbot. It was that it speed up the part of scientific thinking that usually take a very long time. That was the point where it became clear for us, this is real, this is the future. Just to give us some context where we are. Roche operates across pharmaceutical and diagnostics, and R&D is the central of what we are doing. So we really need better decisions here, can ultimate meaning better and faster outcome for the patients. So this is not just about efficiency, it's about really improving how we make decisions, where to focus, what to test, and how to use our time and resources the most efficient way. So where we brought Co-Scientist, as I mentioned before, across the whole organization. So we start from early research to diagnostics and technical development. So the use cases were kind of different, but share the same underlying challenge. Complex scientific questions, a ton of literature to work through, and decision that shapes costly next steps. So these were real problems that we wanted to test on. And make it with a real example here, I took one of our scientists. So she's a DMPK lead. So that means she translates complex scientific evidences into the next drug development process or decision. And the question is really easy. Are we about to commit to the wrong experiment? So the team already set up the stage. We were quite clear, we go with this experiment. And we just wanted to stress test. We know there are agents now, can we do it? So we give kind of the scientific experiment to the co-scientist and ask the co-scientist what he thinks about that. If he can challenge our idea, do we missing something? And this is, again, how we really use it in the real life was in a kind of deliberate way. So it was a live program, it was preclinical, it was under real-time pressure, there were decisions that have to be made, high-stakes decision in front of the team. And they had already done the literature work, the team setting up the experiments, and there was really the challenge, the whole plan. Does it make sense? So we use the stress test, the strategy, connect evidence across domains, generate alternative explanations, and translate these outputs into actual experiments and decisions. And trust through, again, there are agents, they're working amazing, but the scientist always stays full on the loop. The scientist is there, review the decision, and also frame the questions. So we have control about the co-scientist. And to mention here is the 3 important findings that we figure out with using the co-scientist. So first, the team saw that the current strategy carried more risk than they had appreciated. Second, the safety angle had that not been central in the original reason, because became central when it was surfaced clearly. And third, the generated 3 ranked alternative paths that come from the co-scientist, each one was testable and give us a kind of a decision for a no-go or go logic. For me, that is the real value, and not just a summary, but a better challenge to teams' thinking and clear set of scientific opinion. And again, that's also what the DMPK lead said, this changed what we thought we are doing. So they changed the experiment. They took that in the next decision, and this was the output of the co-scientist. So again, the key point is that this is not just improving the discussion, it's changed really the plan. And this was kind of, how do you say that? This was groundbreaking for a lot of scientists in the lab. They were not aware of that. The team clarified what it's good enough means. They make the stop, continue, or escalate, criteria explicit, added essays that had not planned, and moved more information test earlier. So the result was practical, avoiding low information work, redirect efforts, budget, and compressing what really normally takes weeks into hours. As Tom mentioned, we had, I guess, a challenge. The longest one, I think, was 5 days when the co-scientists come back with a hypothesis that we tested. And again, the scientist is always on the loop and accountable for the judging truth. So what was really striking is that the same pattern shows up across very different parts of R&D. So it's not only pharma, also Beyer. Different sciences, different teams, different contexts, but the same bottleneck. Fragmented evidences, several plausible explanation, expensive next steps. That is where the Co-Scientist was the most useful for us. When the question was hard, the literature was really broad, and the next experiment was costly, the value was not only speed, it was really the improving the decision before time and resources were already committed. And so to close that is that what we saw was not just faster access to information. We saw that the tool that could strengthen scientific reasoning across R&D. So in the right setting, it challenged the assumption and connecting evidences, surfaces, and risk, and helped the teams to build better experiments plan. And this is why it matters for us at Roche. And we believe that these kind of agents become really the foundation of the next R&D steps in the next future years. And with that, I thank you and hand over to Rex.
Good morning, everyone. I'm Rex, Principal Data Scientist at Klarna. For those who don't know us, Klarna is a global technology company that powers payments, checkout, and post-purchase experiences for over 114 customers. We process around 3.4 million transactions every single day. My team works on an ML model that powers that network. Today, I'll talk you through how we applied AlphaEvolve to our production training pipeline, provide a few highlights of our pilot, and a few details of our technical implementation. We are developing the core transformer model that is trained on our payment streams. Our model itself isn't massive, but our iteration cycle is. We run through thousands of iterations of training iterations every year. At that scale, training speed isn't just about our cloud bill. It's about how fast our teams can invent. So our goal was simple. It's to make our training pipeline as fast as possible so our engineers can run more experiments. When we tried to implement that, we hit a wall. We realized the bottleneck wasn't just tweaking hyperparameters. It was the underlying plumbing, such as PyTorch abstractions, memory allocations, and how data moved to the GPU. The problem is that with structural code rewrites, it's a massive search space. An engineer could realistically try 5 or 10 different rewrites, but the combination, there are thousands of them. So instead of manually testing each of them, we let AlphaEvolve optimize for us. Now, AlphaEvolve isn't a typical coding assistant. You don't prompt it and iterate back and forth. Instead, you build a strict sandbox around it. There are 4 requirements to build this sandbox. For us, we initially defined the specific components in our training code, telling AlphaEvolve what it was allowed to rewrite. Next, we need to define the target. For us, it's to optimize training throughput measured in samples per second. And we applied 2 different constraints. The first one is our model AUC could not drop. And finally, we must be deterministic. Our training models must be reproducible, because in regulated finance, a non-reproducible model cannot be audited, so it cannot be deployed. With the rules set, we started the loop. AlphaEvolve would generate the candidate code, and our system would take that code, train an actual model, score the results, and send that result back to AlphaEvolve to seed the next generation cycle. Over 3 weeks, we ran through nearly 6,000 candidate programs. We shaped the environment, and the machine explored the search space. Now, in the early generations, the system found the standard performance wins: mixed precision, asynchronous CPU to GPU transfers, keeping metric accumulation strictly on the GPU to avoid sync stalls. That got us from 49 samples per second to about 72. The real breakthrough came when we expanded beyond the training loop. We included forward pass and the data pipeline within the search space. The first breakthrough was flash attention bypass. High-level PyTorch implementations are built for flexibility. So they take slower dynamic memory allocation. AlphaEvolve stripped away these abstractions, these convenience wrappers, and replaced them with a manual loop, directly using PyTorch's C++ backend. The manual loop, in other words, uses scaled dot product attention kernels to make the bare metal hardware do the operation in a single pass. The second breakthrough is within the data pipeline, implementing zero-copy data. Instead of dynamically allocating memory every step, it pre-allocated fixed buffers, contiguous memory buffers, to be reused for the entire training run. And that gave us the 97 samples per second result, all the while being deterministic and reproducible. And then there's PASC, which stands for Proactive Adaptive Stability Control. It's a technique that AlphaEvolve invented without us prompting it. What it did was that it monitored loss for gradient spikes, validated tensors, and reset the scaler when things went wrong. But this was done when we only gave it 10,000 samples of our customer data. But when we scaled up to 100,000 samples, it realized it was adding overhead without much benefit, so it deleted its own invention. From our experience with AlphaEvolve, here are our biggest gains. We doubled our initial throughput from 49 samples per second to 97 samples per second. And our model actually improved in quality, despite our original constraint of not decreasing any. And finally, we were able to, the biggest gain that surprised us was in setting the deterministic constraint. Initially, AlphaEvolve was taking shortcuts by optimizing by using techniques like TensorFloat32 benchmarking. But later on, we implemented deterministic constraint, and AlphaEvolve was forced to discover deeper architectural rewrites. The training loop is just one pattern, but the underlying pattern generalizes to a lot of different problems. If you have a clear metric, hard constraints, and a code-level search space that is too big to explore by hand, you have an AlphaEvolve problem. And here are just a few examples that we are exploring at Klarna. Simulation-driven exploration that are complex policy trade-offs that are too large for humans to navigate. Or we're trying to optimize tokenization as a true optimization problem instead of relying on standard heuristics. And finally, optimizing the fraud model under strict policy and strict latency constraints. The sandbox is the same, but the domain changes. Finally, the main takeaway from our experience using AlphaEvolve are three things. First, leverage constraints as catalysts. Don't be afraid to define a strict sandbox. It forces the system to innovate deeply rather than taking shortcuts. Finally, you want to also, second, optimize cross-cutting architecture. You should let it explore different things from memory allocation to data transfer and horizontally and vertically so that it could handle things that typically humans can't attempt. And finally, complexity isn't always an asset. Sometimes the best optimization is the simplest, where the system deleting its own clever inventions. The future of AI and software isn't just about what you can prompt an LLM to write. It's about building environments where algorithmic evolution can continuously redefine the limits of your system. The full story is on our joint blog with Google. The QR code's here, and thank you.
Good morning, nice to see you all. My name is Mateusz Klimowicz. For last years, I have been working in continuous improvement department in FM Logistics, focusing on making logistics smarter and more efficient. Our company is a logistics service provider for many different world-known companies, brands, And as I know, as I check, many of these companies, many of the representatives of these companies are also present today in this room. In this presentation, I would like to show you how we are tackling the traveling salesman problem described earlier by Tom, how we work with this problem in FM Logistics in real warehouse operations using AlphaEvolve. This is one of the most known and most complicated combinatorial problems in the science. And the difficulty in this problem is growing with its scale. This problem, in general, we can say, is present in many logistical operations which are happening all the time, all around us. And these operations affecting almost every single item we buy. And I think this is the potential improvement field where utilization of this technology will make the impact. I will drive you through our journey with AlphaEvolve, first by describing the problem we wanted to solve, then presenting the impact, the results that we achieve, showing you the timeline, describing the solution, the inventions made by AlphaEvolve, and previewing the next logistical operations that we want to improve by utilization of this technology. Starting from the business problem, in one of our e-commerce warehouses in Poland, which we select for the pilot for this project, we collect, pack, and ship over 10,000 orders every day. The area of this activity is huge. It spans about 8 football fields and 18,000 different pickup locations for collecting various items. Each worker travels through the warehouse while collecting 16 orders at one run. And each of these orders, each one of these 16 orders may have to visit 1, 2, or even 10 locations, depending on the size of the order made by the customer. Potentially, worker can visit up to 100 locations and even travel a path of over 3 kilometers. So this is our scale. The objective and the challenge in this project for AlphaEvolve was to optimize the algorithm which is responsible for planning these sets of the orders together to minimize the travel distances for workers. Yes, because in logistics, generally, the travel distance translates directly to cost, which we would like to minimize for us and for our customers. We could generally describe the logistics as the business of meters and seconds. With the new algorithm co-created by AlphaEvolve, we achieve a 10% reduction in total distances traveled by workers and forklifts. This translates for us to a saving of over 15,000 kilometers traveled inside the warehouse, so inside the building, every year. All this allows also to accelerate the lead times of our processes and increase the capacity of the whole facility. And all this with no major investment in equipment, infrastructure, or additional training, just by better utilization of actual resources and smarter code thanks to AlphaEvolve. When we start our work with AlphaEvolve, we already have an existing algorithm which let us save over 25,000 kilometers every year. And AlphaEvolve's improvement is built on top of that, where every subsequent gain is much harder to take. We consider this old algorithm as near optimal, with very little room for further improvement, much lower than we achieve with AlphaEvolve. We also have tried different machine learning models, but in our case, none of these models beat our old algorithm. And after reaching this point of optimization, the Google team gave us access to AlphaEvolve. So within about 1 week from obtaining this access to this tool, we managed to get the first fully operational solution with the first improvement in just 1 week. Yes. Then, within the next month, with the series of different experiments, we get the final solution, and in the next 2 weeks, we were able to implement this solution to the production environment, which we are now successfully using today. The AlphaEvolve brings several key improvements to our initial algorithm, which is unlocking its full potential. First, what is the most important here, it invents and introduces a group of new, very smart heuristics, which helps us to make better choices of orders to be included in the set of the orders. Yes, There are separate heuristics which helps us first to choose the, let's say, anchor points where we start these sets of the orders, and then other group of heuristics helps us to choose the subsequent orders to create the, let's say, most optimal at a given time, most optimal possible solution at the given time, combination of the orders. In our scale, as I mentioned, with these thousands of the locations, there are millions of possible combinations how to complete this task. So, and calculating them all to find the most optimal one would take weeks, or not months. So the timeliness here was also one of the criteria, which was fully with some calculation tricks also invented by AlphaEvolve. What was also the challenge in general for this project, or in, let's say, in the cooperation with the AlphaEvolve, is to correctly adjust and create the evaluation script. But after doing this in the series of the smaller experiments, the final solutions returned to us by the AlphaEvolve appears to be almost plug-and-play type of solution, which demands only very small adjustments to be later put to the production environment. What is also important for us, and I think for everybody who will use this solution, the solution given by the AlphaEvolve are fully readable for developer and then also for the business. Yes, business will always want to understand what is going on, for example, in the warehouse. So for us, this is only the beginning. Our company sees great possibilities in utilizing this technology in logistic processes and in optimizing the logistics. What we already began is the scaling of the algorithm which I described to other e-commerce facilities where we conduct this type of the operation for other customers. What we plan to do next in the next phase is using the AlphaEvolve to optimize the algorithm responsible for planning the placements of product around the warehouse. This can bring the further significant decrease of the travel distances in all warehouse processes, in addition to actual gains in the picking collection process. And last but not least, there is also a massive potential in utilizing this technology, in using AlphaEvolve, to optimize the algorithm responsible for planning the road transport activity. You can imagine a 10, 20, maybe even 30% decrease in the travel distance traveled by trucks. It will not only reduce the usage of the fuel or speed up the deliveries, but it could, in general, decrease the carbon footprint of the whole operations of the whole supply chains. In my opinion, for logistics, the AlphaEvolve is really a game changer and something what is worth to use. Thank you.
Cool, yeah. Thank you so much, everyone, for joining us. Really, a big thank you also to our speakers today. We're really excited about what we're going to do jointly together to use Co-Scientist and AlphaEvolve to solve real-world problems together. I think there's a significant opportunity here for all of us to really use these underlying technologies to achieve real scientific breakthroughs. And so with that, I'm gonna thank the audience again. Thanks very much for joining us today. Let us know if you have any further questions. I think a few of us will be standing here or outside of the room to answer any questions that you might have. We also brought a friend from our GDM team along with us if you have very specific question. Thank you so much for joining us.